Simplifying expressions. Simplifying expressions. Now, we know what expression is, I hope, but just in case, let's go back through that. All right. So if we have a problem that says 3m squared n minus 4mn squared minus 8. Let's just start there. This is an expression. An expression is anytime you have a math problem that don't have an equal sign in it. That's an expression. Just very basically saying. It's a math statement that does not contain an equal sign. Now, we learned something on Monday 7 days ago. I asked you, what are the terms? Somebody real smart, tell me what the terms are. Comma, what else? Somebody real smart, help them. Thank you. Negative 4 what? And the last term. All right. That's what we learned on Monday. We learned how to look at a math statement and how to identify the terms. Next, we asked about what we want to know, the what? Coefficients. Give me the coefficients. 3 and negative 4, very good. And what are the constants? Negative 8, very good. What is the difference between a constant and a coefficient? There you go. Constant standing by itself. It don't got nobody with it. Coefficient, it can have one variable or many. All right, good, good. That's what we talked about on Monday. Very good, y'all. Y'all the best so far. All right. Impressive. All right, let's keep going. Now, we know what expressions are. We know the parts of an expression. Let's talk about what does simplifying expressions mean, all right? When an expression is simplified, a simplified expression has no parentheses, and no like terms. Now, you know, simplify means give me the answer. But when you have an expression, it means you can't have any parentheses in there and there can't be any like terms. Now, we know what this means. We know what everything means. We know what the parentheses is, but we got to go over what are like terms. That's what we started today. And we're going to stop on that as well. All right, here we go. Let's talk about like terms. Like terms, these are terms that have the same variable put an S on it, put an S in parentheses. That means one variable or two. Variable or variables that have the same variables with exactly, underline exactly the same exponents. And if you have an S, you may have more than one exponent in that term. All right. Like terms are terms that have the same variable or variables with exactly the same exponents. Exactly the same exponent. That's all a like term is. All right. So let's jump in the water and see what we got with using that definition. All right. Write this down. Examples. I don't know how I'm going to do, so we'll just say examples. Here we go. I need that right there. Yeah, here we go. All right. Let's try negative 2x y squared z comma 3x y z comma x y z comma, X, Y, Z, comma, X, Y, Z. All right. Let's see if we make sense of those hieroglyphics one student called it. What is that? It's just letters. Okay. This is what I want you to do. I want you to first always go to your first term and circle the variable part. Circle the variable part. Negative 2's variable part is xy squared. Those belong to him. That's his. Who else has like terms like negative 2? Who else does? Very good. Negative 1 also has x, y squared, z. Anybody else? Positive 1 has a x, y squared, z. Now let me break it down for somebody. Well, let's ask together. What's the x? Now, do all three of these have x, y, z? Yes. So they have the same variables. All right. Let's now check the exponent. What's the exponent on the x? Thank you. If you don't see a number, it's an understood 1. You can't say that's a 2 for that x. It ain't. He got his own exponent. So what's the exponent on this x? No, that's a coefficient. Exponent. 1, right? What's the exponent on this coefficient, on this exponent? 1, all right? Let's check the y. What's the exponent on this y? What's the exponent of this y? What about this one? So far, so good. What's the exponent on this z? Huh? Yeah, if you don't see a number, it always understood 1. What's the exponent of this z?
1.
And the last one?
1.
All right. So because they have the same variable and each variable had the exact same exponent, that makes those like terms. Now, I want you to draw a box around the second set of variables. That's 3's variables right there. That's his people. X, Y, Z, but they're kind of different. Is there a like term that belongs to x squared, y, z? No. While the one that's left over does have an x, y, z, what's wrong with it though? The y got a squared on it. That makes it not like him. So the last group of terms, I want you to draw a triangle around those. There are going to be some terms that's going to be alike that you're going to put together. There's going to be some that you're just going to have on the side because they don't go with nobody, but they're still a part of the neighborhood. Let's do it again. Let's do it again. Next example. Let's slow it down a little bit. 5P 7Q negative 4P and 5P. All right. Okay. We are here to identify who's like and who's not. The first thing I want you to go is go to your first term. I don't have a variable with that one, so I'm just going to underline that 5. Do I have anything that's just like that 5? No. What is that 5? What we call it? Is that a coefficient or a constant? It's a constant. There are no more constants in this line, so no one else is like him. All constants are like terms. 5, negative 3, 800, 15. All those would go together, but we don't have any more. So we go to the next one. Now to circle P. What term do you have that can go with this P? Oh, so this P here, and what else? Yeah. Now somebody want to ask me something, but you ain't saying it, so I'm gonna go ahead and say it. How they like and one negative and one positive? Who asked that? I already know. How they like when one negative, one positive? To answer your question, look back at the definition. Like terms are terms that have the same what? Variables and what? It never said the coefficient had to be the same. Never. They ain't got nothing to do with it. It's variables with the same exponent. That's all you look for when you're looking at like terms. And then the one that we don't have one with, that's left over, is Q. All right, let's crank it back up. Let's crank it back up. Here we go. Pay attention. What is this one? V squared, U squared, W. 2 U V W. 8 U V W. 3 U W V. And U V W. Stay with me now. I'm scared you're gonna miss something. Good. 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 All right. Now, let's circle the. Okay. Okay. I'm sorry. Man, I should say SWV. God dog it. I should have did that, man. It's always late, man. When I record, I'm gonna switch it up. They already wrote it, y'all. See what I'm saying? Now, remember now, this is not math. This is you playing a matching game. That's all it is. If you think about it like math, you're going to mess something up. It's just a matching game. All right? So here we go. We're going to circle the first group of terms, of variables. Here we go. Now, where is this like term? Where is this like? You don't see one? Let me help you out. This is one of the like terms. The rules only said they have to have the same variable and same what? So here we go. Do both terms have UVW? All right, let's check the exponent. This one has V squared. Does this also have V squared? This one has U squared. Is this also U squared? This is W to the first. Is this also W to the first? That makes it like. It does not matter that they are rearranged. On standardized tests, they do this on purpose all the time. You have to know that if you see them out of order, put them in ABC order. Make all of them UVW if it helps you. But they all like terms. So with that information, is there another like terms with this VUW? Is there another one? Where? Who's? The 3. He has V squared, U squared, W. If you say it out loud, it has to sound the same. U squared, V squared, W. I see it. Is there another one? It is. These are all like terms. You just cared that they had the same variable with the exact same exponent. It don't matter the order. And then put a box around this one because he wouldn't have anybody. All right. So this is identifying like terms. The last thing I need is combining like terms. Combining like terms. All right. Now, this is one of the steps of simplifying. The last step of simplifying is combining, so I'm teaching you that first. Combining like terms, you have 2 steps. Step 1 will be to line the like terms up vertically. If you got a 40-inch vert, are you jumping from side to side or up and down? No basketball players in here? No? Oh, okay. We got one. We got a couple. All right, when you find like terms, line them up vertically. All right, and then step 2. Combine. Combine mean both add and subtract, but combine coefficients only. Combine the coefficients only. And I put this part, bring down variable. Bring down any variables you got. That's it. All right. I'm going to put a problem up and I'm going to show you how it works. And we'll get more practice on it I'll tell you. Here we go. Example. Second group of examples. Just one. 3m cubed n minus 4mn cubed minus mn minus mn plus 4m cubed n. All right, that's a real live problem right there. And our question says, combine the like terms. That's what it's going to take you to do. Or simplify. Make it so you have no like terms in your answer. All right? So what I want you to do, when you do this problem, you first write down the first term that they gave you. I gave you 3 cubed mn. 3m cubed n. That's our first term. Do you have any other term in that group that's alike, that's like with that one? Who? Huh? The -1? Put it right under this one. -1 m cubed n. Any more? The last one. So you say 4m cubed n. Any more? Cross out what you use. Cross out what you use. Because if you don't, I've seen it every semester, you can write it again. Cross out what you've used. All right. Now, we go into our next term. What's our next term? What's next on the list? Say the whole thing? Yeah, so -4 mn cubed. All right. Now, do we have a like term with this mn cubed? -1 mn cubed. And you underline the whole problem. Don't forget to X out what you already used, so if you want to go check yourself. Now, when you underline what you've already used, in your calculator, this is your plus sign. That means everything will have a plus in between. So, 3 plus -1 plus 4. How much is that? -6. So remember, combine the coefficients. That's all we did. 3 plus -1 plus 4. We got -6. What you going to do to these variables right here? What did it say? Bring them down. So I asked somebody and they told me. I cheated. Oh, I agree. I agree. Whoever told me negative, you should see it. I mean, you only give an answer, I'm going to take your answer. I'm just saying, y'all better check each other. I'll be on the video and be like, God damn. But anyway, y'all better check each other. All right? So, 3 plus -1 plus 4 is 6. And you bring down the variable part, correct? All right. Now we move over to this part over here. -4 plus -1. How much is that? -5. And what you going to do to that variable part? Bring it down. That's combining like terms. That's what we're going to do. We're going to line the problems up. And we're going to line the like terms up. And that's what we'll be working on for the next couple of days. Now, on your work for today, God dog, I got to join the race. All right? What I want you to do is pick a column. Pick a column. Either you're doing from A Either you're doing from A to U, B to V, C to W, or D to X. Only thing I'm telling you to do is whatever column you pick, also add Y or Z. So whatever column you're getting, add Y or Z. I want you to apply the rules. For instance, if you pick B, you'll do this. Line them up vertically. Coleman, you with me, man? W, 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 W. That's all right. So 1, 2, 3, 4, 5. Underline. What number is that? What's the coefficient of all of these? A 1, right? So your answer will be 5 what? That's it. Now, I ain't tricking you. All these are like terms. You line them up. It's something I'm going to do when I put this together. So I need everybody to see it. And you see them vertically. And you combine those terms. All of them are alike. No set has different terms.